So here we are back in section 2.8 of geometry, last section, and before our test, so let's make sure we're on point. So looking at this example 4, we're going to use the thing we just proved. We did it, that vertical angles were congruent, that vertical angles are congruent. So we proved it, now we can use it. So we're going to prove that if DB, that's this segment right here, let me highlight it for us, if DB bisects ADC, then angles 2 and 3, angles 2 and 3 are congruent, and we need to figure out how we can do that. And I want to honor what I said before in terms of how I want to color this. This is a given concept, so I want to leave that there, and I'm trying to prove that basically 2 and 3 are the same. And so I'm going to highlight that in red. And sometimes for me it's helpful to kind of keep my eye on the prize, as it were, right? Keep my eye on that which I'm trying to do. So that's why I do that in red. All right, so the given information is that this thing bisects that, and so bisect means that it's going to break these two guys into equivalent angles. And hopefully you're kind of seeing something that's happening here. And remember, we're going to use vertical angles. So let's see what we got. So the first thing that we might want to do is put down our given information. Cool. So now that that's done, we do have to do some thinking through. I want to eventually get that these two red things are equal. What do I know? We're going to use the vertical angles. That's up there underneath the thing there. And I'm also going to use the idea that, okay, these two angles are equal. I guess I should put that down. Angle 1 and angle 2 are equivalent to one another by definition of an angle bisector. Okay, so now that that's out of the way, I've got that bit of information. I'm trying to get 2 to 3. Can you see any way that I can relate some of this stuff together? Hopefully you can see that 1 and 3 have a relationship. Remember what we just proved? I can prove that the measure of angle 1 is equal to the measure of angle 3. Well, in fact, I think the better way to say it is that angle 1 is congruent to angle 3. And we got that because why? Remember, vertical angles are congruent. We just proved that. Vertical angles are congruent. I'm going to write it like that. And so the fourth thing that I want to say is I want to see if I can get all of this stuff equal. Well, then I'm going to say that the measure of angle 1 is equal to the measure of angle 3. And this is simply by the definition of congruence, right? And now that I've got that, can you see where I need to go? Remember, I'm trying to prove that these guys are congruent. And if I can prove that they're equal, then I can prove they're congruent. That's not too bad. So I'm going to play off this situation here. If this is the case and this is the case, then I'm sure that by transitivity, I can say that the measure of angle 2 is equal to the measure of angle 3. And since I can say that, and this is a transitive property of equality, right? Since I can say that, now I can simply say what I wanted to say for a long time. I'm awesome. Sorry. I'll say that later. I can say that the angle 2 is congruent to angle 3. Kind of beautiful, right? And we can also use definition of congruence for that one. Okay? All right. And so ending up this chapter, we have some concepts that you really should read through. I'm going to read through it with you. Sometimes it's hard to listen to somebody read something that's on the screen, but just sit with me. You can put your pencil down and just listen to my mellifluous voice. All right, maybe not so mellifluous, but check it out anyway. So looking at section 2.9, or theorem 2.9, basically theorem 2.9 is telling us that perpendicular lines intersect to form 4 right angles. That makes sense. So it says, hey, if you have 2 lines that are perpendicular, you can know that all of these angles are 90 degrees. And you knew that already, right? So we can prove it, but we just needed to say it. Some of these things are going to be kind of obvious, but we just needed to state the thing. Okay, all right angles are congruent. Yup, that makes sense. If it's a right angle, then it's 90 degrees. And if it's 90 degrees, then it's equal. And if it's equal, then it's congruent. So we can prove that pretty simply. So all right angles, angles 1, 2, 3, 4, if they're all right angles, then they're all congruent to one another. Perpendicular lines form congruent adjacent angles. So if the lines are perpendicular, then the angles next to each other, adjacent angles, remember, share a side. So if the lines are perpendicular, then the angles that are side by side are congruent to one another. They're congruent because what? Because they're 90 degrees and we know all 90-degree angles are congruent. All right, let's go back down here to 212. If two angles are congruent and supplementary, then each angle is a right angle. Let's say that again. If two angles are congruent, let's say 5 and 6 are congruent, and they're supplementary, when we add them up, we get 180, then each are right angles. Well, that makes sense. Congruent angles are the same. If I've got two angles that are the same that I'm adding together and I'm going to get 180 degrees, best believe that those angles are 90-degree angles or right angles. And finally, if two congruent angles form a linear pair, two congruent angles are side by side and they form a straight line and they're congruent, then they are right angles. And so we've got a whole lot of information here, but I think it makes total sense, and I think you get it if you follow along. If I was talking too fast and you're like, I don't know what's going on, do take the time to just read through it and just say, yeah, I got this. And so this can be found in your textbook in section 2.8. I look forward to talking to you soon. Make sure you do the practice test and check it. And let's get ready to finish 2.8, do the practice test, and go on to the test, and then get ready for chapter 3. Take care. Have a good one, guys.